Welcome to day 6 of our challenge. Today we'll be looking at how to generate stratified estimates, which means how do we break down our results by various characteristics. For example, if we look at our case study, our model report where we're looking at tobacco use among adults, let's go to table 1. So here you can see that we've broken down the results by various characteristics like sex and race and age and so on and so forth. And the reason why we do this is so that we can be able to detect if disparities exist in tobacco use. For example, when we look at any tobacco use by gender, we can see that males have a prevalence of 24.1 and females have about half of that. That tells us that, wow, there are wide gaps in tobacco use by gender, and there is something we should do about it. That's why we break down results by characteristics like age and sex. Now, when we're doing this, there are certain things we want to watch out for. The first obvious thing is, should we present results with the confidence intervals or should we present with standard errors? That's a decision you have to make as an analyst. Personally, I always prefer showing the results with confidence intervals because that's what most people are used to. But those two things are exchangeable. You can choose to do your presentation with confidence intervals or with standard errors. The next thing we want to do is to make sure that we suppress estimates that are not reliable. Here, for example, you see this cell here has a dash, as well as this one here, and many other ones. These ones here also have dashes. These are estimates that are not statistically reliable. If you go down to the footnote here that explains that, it says that these are unreliable estimates that were suppressed because the relative standard error was more than 30%. So that's something we'll have to learn how to calculate as well. So let's go over to the chi-squares platform and let's see how we can calculate those things. Let's look at the task list for today. The things we're supposed to do for day number 6. So the task says that we're supposed to replicate some of the analysis in the report we just saw. And specifically, task number 1 says we should calculate the prevalence of these different tobacco products and stratify the results by age, gender, and race. Let's see how we can do that on the chi-squares platform. So we'll head over to the platform. We are already in our project. And since we're trying to calculate prevalence estimates, we'll go to estimates and we'll select prevalence. We can then select our outcomes by typing in CURR for current, and we'll select all the outcomes that are applicable. Let's remove this. So there are 6 of them: current cigarettes, e-cigarettes, cigars, smokeless tobacco, current combustible, and current any tobacco. There's actually a typo here. These are triple R instead of double R. But let's proceed. So done selecting. And next we'll select our stratification variables, which are age, cat, then gender, then race, right here, and done selecting. Here, this is a variable selection we will do if we were analyzing trends over time. But in our analysis, we're using only one data point, which is from 2024. But if, for example, we had pulled data from 2020 to 2024 and wanted to see how prevalence changed over time, we will have selected a variable for year, for example. But in this case, that does not apply. Then here we are analyzing the entire data set because we are trying to calculate prevalence in the overall population stratified by this variable. So this will be the entire data set, not a subset. There are preferences here to select what we want or how we want to present the results. We can control the number of decimal places. In general, we always present prevalence estimates to 1 decimal place. Next, we have the option to suppress unreliable estimates. Yes, we absolutely want to select this. And once we check that box, it displays an option for us to select the cutoff using the relative standard error. And as we mentioned earlier, we typically use a cutoff of 30% to indicate estimates that are unreliable. Next, we have the option to choose whether we want to display results as percentages with confidence intervals or percentages with standard error. You can choose whichever you want, but by default, it is with confidence intervals. Once you're satisfied with the options, we can then click on Apply and then click on Estimate. So what the platform then does is it takes all of those parameters that we have input, that is our outcome variables, our stratification variables, and whatever preference that we selected in terms of number of decimal places and the measure for reliability if selected, and it will apply them in calculating our prevalence estimates. The one thing we want to also pay attention to is the checkbox here, which we're going to discuss in tomorrow's challenge. This is for computing weighted population counts. We'll focus on that tomorrow and discuss in detail what it means and how we can do it properly. So here our tables have been calculated as we desired. The platform has calculated the overall estimate, which is the first row, and then you have the results broken down by age, by gender, and by race as we specified. The estimates have been provided as percentages with 95% confidence intervals, and here you see some estimates are not shown. For example, prevalence of current smokeless tobacco use among Asians was not displayed, and that is because we chose to suppress estimates that were not reliable. So that's how you calculate prevalence estimates in terms of overall estimates and stratified by various characteristics. Now let's go back to the task number 2. Task number 2 says estimate the percentage of adult cigarette smokers that smoke menthol cigarettes, stratified by race. The hint here is that our outcome is menthol, the stratification variable is race, and this time around, we are not analyzing the data among the whole population. Rather, we have to subset our analysis to current cigarette smokers. In other words, this is what we want to generate here. We want to create data for a figure like this, showing the percentage share of menthol cigarettes among current cigarette smokers. Whenever you see the word among, that is telling you that the analysis has to be a subset analysis. It is no longer among the whole population. So here we're saying, among current cigarette smokers, what percentage of them smoke menthols? So that's what we're trying to calculate. So let's head over to the platform again and see how we can execute that. So let's close this. This time again, we'll come to estimate. Again, prevalence. We'll choose our outcome as menthol. So let's search for menthol. We'll select that. The stratification variable here is race. So let's search for it. This is right here. And the analysis is supposed to be among current cigarette smokers. So this time around, we're going to select a subset and we'll define that subset. Let's add variables and define it by current cigarette smoking. This is it right here. So select this, done selecting. So if value of current cigarette is exactly equal to 1, let's check the sample size. So there are 3,363 individuals who have a value of 1 for current cigarette smoking. And we're saying that the analysis above here should be limited to this subset. So once we're done, we can click on Estimate. So in this case, the platform takes the data here or the selections here and applies the weighted analysis onto this subset. This is the correct way of analyzing subset. We never ever want to drop rows and then bring the subset analysis or the dropped rows to the analysis, because in that case the confidence intervals will be incorrectly estimated. So here we have our results showing that 32.1% of US current cigarette smokers smoked menthol, and these are the distributions by race ethnicity. So this forms the results, for example, that were captured in this particular table. So you can see here, overall 32.1. This is where this number came from. So this shows you how you can calculate prevalence estimate among a subset of the population. Then finally, let's look at the third task for the day. It says calculate the mean number of cigarette packs smoked in the past 30 days among daily and Sunday smokers respectively, each stratified by occupation sector. So here we're interested in means. So let's go back here, and we're interested in the mean of this variable. So let's go back, or we can just close this. And this time we're going to estimate. This time we're not coming to prevalence, we're coming to means because we're interested in mean estimates. So we click on means. The outcome variable is total number of cigarette packs smoked in the past 30 days. We select that and click on done selecting. The stratification variable is supposed to be by the work you do, the occupation. So we select trade. And mind you, what we're trying to replicate is this figure here, where we calculated the average number of cigarette packs smoked in the past 30 days broken down by your occupation. So we have selected our outcome, which is total number of cigarette packs. We have selected our stratification variable. But as you can see in this figure, we analyzed and presented different bars for Sunday smokers and daily smokers separately. So that means that we want to run the analysis in such a manner that we have Sunday smokers separate from daily smokers. So first of all, let's look at the results among daily smokers. And so here we'll have to select the indicator for what daily smokers are. The hint here tells you that the variable that indicates whether someone is a daily smoker or a Sunday smoker is this. So they have a value of 1 for daily smokers and 2 for Sunday smokers. So we can select this and, wrong field. We're selecting among a subset and add a variable. This is the subset we want to restrict it to, these individuals. And if value of this is exactly equal to 1. So here we're looking at among daily smokers. Let's check the sample size. So we have 2,513 individuals who are daily cigarette smokers. So we're trying to say, what is the mean number of cigarette packs smoked in the past 30 days, stratified by your occupation, among daily cigarette smokers? So let's estimate this. So when it comes to non-daily smokers, we're going to do the exact same thing, but this time we're going to then change this value to 2 because 2 corresponds to non-daily smokers or some day smokers. All right, so here we have our results presented overall and by occupation type. So you can see here that among daily smokers, the average number of cigarette packs smoked in the past 30 days was 21 packs. If we go back to the results from our MMWR, our report, see overall 21. This is where that number came from. And then broken down by the different groups. So among those in the arts and entertainment, you have 25.4. Let's see where that number came from. Among those in the arts, 25.4. So you can see how those numbers add up and how they are generated. If we wanted to analyze it by individuals who are some day smokers, we'll change this number from 1 to 2. How do I know that it's 2? From the documentation. This is why you must read the documentation. And let's check the sample size. So we have 850 individuals who are some day smokers, and we can click on estimate. Again, the same thing happens. So in a nutshell, that's how we generate estimates that are stratified by subgroups. You want to make sure that you have applied weighting correctly. In this case, our analysis mode is weighted. You cannot omit this step. Otherwise, your results will be invalid. And once we have set that, we can then select our outcomes, our stratification variables, and if necessary, we can subset the analysis to a subgroup. Otherwise, it's among the whole population. So that's how we generate estimates in terms of overall and stratifying by demographics. I look forward to receiving your submissions and your reflections on the questions for the day. Thank you.